this simplifies down quite nicely using the double angle formula to cos k plus 1 or cos k theta plus theta and factorized out theta. And this right hand side, or the right side of the right equation, simplifies down to the sine k theta plus theta, with theta being factorized out here in this form. This leaves us with this equation here, which is that cos theta plus I sine theta to the power k plus 1 is equal to cos k plus 1 theta plus I sine k plus 1 theta, which is what we expected. We went down the logical steps and we ended up with this pattern, which adds evidence to the idea that whatever the power is here, we will end up the coefficient in here. So for n equals k plus 1, we have that cos theta I sine theta k plus 1 is as follows. We have proven it true for n equals 1. We assumed it was true for n equals k, but what matters more is that it's true in terms of the structure and the pattern that occurred as a result of going through all the mathematical logical steps, for which each step we know to be true. So therefore, if it is true for 1 and it is true for every step forward in integers, so 1, 2, 3, 4, and 5, then it is true for all integers that are greater than or equal to 1. And we can assume, with for our understanding of knowledge, that is, which is limited, of course, because, for example, you have no idea, this is random, but you have no idea whether I was switched with a twin of myself and that is who is speaking. So there is limits to our capacity to understand, or capacity to say that knowledge is true. But for our understanding of the mathematics we have, we can suggest that z to the power n equals Rn cos theta plus I sine theta to the power n can be written as, this can be written as Rn cos n theta plus I sine n theta, if it is going to, if, for example, you assume only for n is greater than or equal to 1 in integer steps. And this is advantageous because then it allows for us to work on the following, that is, the problem that we had.